Good morning. I'm so delighted to be here again. I actually sort of tried to invite myself back because I love you all. You're my favorite crowd because I learn a lot from all of you in the conversations that we have, and maybe even more so than you might learn from me. The title of the talk on your program, I think, is Revisiting Frequency versus Seasonality of Fire. I changed it up a little bit here because I want to talk more broadly about fire regimes, because I don't think we truly have this dichotomy of season versus frequency. It depends on what our management goals are, and it depends on the community that we're burning. So there's a lot of little intricacies there, and I'm going to hit on some of those today. Now, I will encourage you, if I don't get to the end of my talk, it's not a big deal. If you have questions or you have comments, please feel free to raise your hand and stop me along the way. Also, I'm told I have to stay behind the podium. So you in the front row, if you see me, start to dance around because I'm very excited about fire and leaving the podium. Please make sure to tell me to go back. So I've been working in fire a long time. And how do I do my next slide? Okay, so I've been in fire a long time. I won't tell you how long I date myself. But I started when I was about 20 years old. I was invited to burn the prairie with the Nature Conservancy and absolutely fell in love with fire. I caught the fire bug. And it wasn't just the burning, although it was very fun to hold the drip torch and wear a banana suit. But it was also afterwards. I'll get this figured out. Going back to revisit that prairie every day on my way to class. And I saw the plants regrow, I saw them start to flower, I saw the pollinators come back, and I just gained such love and appreciation of fire. And it told me at a young age, this is what I want to do. This is where I want to be with my life, and I want to dedicate my life to working in fire. And in fact, that's what I've done, spreading the word that fire is an integral part of our natural ecosystems. I am a university professor, and some of you might think I'm in an ivory tower, but I do try to keep my boots on the ground as much as possible. I do teach classes on burning, take my students out, and we actually do prescribe burning in my class. I have at least one former student here today. And I've also been a wildland firefighter. I worked for a little over 2 years out west as a wildland firefighter. So I have this breadth of experience, both fighting and lighting fires. But I also consider myself an igniter of curiosity and curiosity with my students and with those that I work with. And then you all ignite my curiosity also, because some of my research has actually been born from some of the questions that you all have asked me. And I think, oh, we don't have an answer to that. Let's do a research study. So last time I gave a presentation here, my main message, and I'm going to keep this main message. If you're burning, you're doing a great job. We have so many constraints with burning, whether it's weather or getting enough people on the fire line, or trying to design our fires to meet specific goals, that if you're getting fire on the ground, you're doing a really great job. Now, we do know that when we burn, that we want to burn specific to our community that we're burning. So different ecosystems need different fire regimes. According to the Florida Natural Areas Inventory, we have 42 native communities in Florida, and 16 of those are fire dependent. And that means if we move the fire away from what we consider the traditional fire interval, then we're going to start seeing changes in those communities. So fire frequency is important to make sure that we're not seeing significant changes in our communities. And this is, we know this is fire 101. You change the frequency, you reduce the frequency, you start to get more woody plants. And we see that in this series of photos here, where areas that were burned every single year are mostly grasses and forbs. Those that are burned every 4 years, you start to see some of those woody species grow within those communities. We know that we can also alter our fire seasonality. Fire seasonality is sort of a hard thing to talk about, and that's because many studies define fire seasonality in different ways. It's important to actually look within the methods if you're reading a paper to see what they actually say about when they're burning and where they're located. Places that are further north, they might have different definitions of winter, spring, summer, and fall. Some people also use growing and dormant, but we know in South Florida, plants grow all year. So it's really hard to even say, growing and dormant. Wet and dry is another terminology that's used, and also lightning and non-lightning. We've been trying to move a little bit more towards using, wet and dry seasons, or lightning, wet lightning season, dry lightning season, and those sort of things, because it really tells us more about what's happening in that ecosystem when we're burning. But be careful when you say growing and dormant, because people have different ways of defining these, and I'll try to define them pretty clearly when I'm talking today. So we've kind of talked a little bit about fire frequency. Fire frequency, that's the one, you got to get your fires in there frequent, even if you maybe can't get the season that you want based on your objectives. Getting that fire frequency is really important. And I searched 1950s radio. This is what came up. Many of you may not even know what this is, but this is a radio, old radio, where it has two knobs. It has this larger knob, and that gets you kind of close to your radio station, but then there's that fine tuning knob, and that gets your station coming in really clear, okay? So I always think of fire frequency as being that big knob. You're getting there, you're getting pretty close, right? And then the fine tuning knob, that's your seasonality. That's getting you right exactly where you want to be based on your objectives. So I'm going to tell you a little bit about what we see in terms of effects of fire season. And I'm taking these from the literature, and I'm going to try to be very clear about some of these results. And the first one, sorry, we messed up with the wording there, but growing season fires increase the synchronization of peak flowering times. This was a study done by Bill Platt and others in the late 1980s, where for multiple years, they did bi-weekly surveys of the plant communities in areas that were burned during different months. So burned every 6 weeks through the entire year, multiple plots, very large term study in St. Mark's National Wildlife Refuge. So what they found was that when you burn during the growing season, June, July, August, what you see is synchrony of flowering. That means that the plant species that are flowering all sort of flower at the same time. It did not affect the number of species flowering. So even if you burn during the dormant season, there was no change in those species that did flower, but it did change how long they flowered. So when they burned during the growing season, the amount of time they were flowering was slightly shorter, but they flowered sort of all at the same time. So that's what that study means. It does not mean, and I've heard it misquoted, you get more species flowering after growing season fires. They didn't find that. We do know fire season affects wiregrass reproduction. We've got quite a bit of research on this over time. What we found, this is a study by Dr. Baruzzi back there, is that when you burn during the winter or January, very few plants flower. You will get a little bit. Some plants will flower, but then those seeds are very unlikely to germinate. So it's not producing seeds that germinate. If you burn during the spring or March, we actually found higher reproduction, more flowers, but fewer of those seeds actually germinated. In fact, very few of them germinated. But if you burn during the summer or June, you have slightly fewer of those flowering palms, but more of those seeds germinate. So burning, during the summer months, during this time, you will get more of those seeds that are able to germinate. Of course, important for if you're collecting those seeds for any sort of restoration project. Yeah.
Was that in Central Florida? Where, I guess where it was?
Yes, thank you. That was Ordway-Swisher Biological Station. Yeah, thank you. This study, many of you know Mary Neil Armstrong. This was also done at Ordway-Swisher Biological Station. This is about 20, 30 minutes north, depends on how fast you drive, north of University of Florida. And she found that fire season and time since fire both affected seed production. She found that flowering patterns were not indicative of seed production. So she was really interested in, okay, if land managers are going out to collect seed and they want to collect a high variety of seeds for their restoration project, when should they burn beforehand? And her conclusion was basically collect seeds from areas that have burned during different seasons, because not every plant species responds the same to fire. In some cases, and I showed you that with wiregrass, you might get more flowers, but you get fewer germinable seeds. There are other species where if you burn during the growing season, you're going to miss them if you're collecting seeds. So Sargassum secundum, when you burn that one during the summer, you end up not getting any seed production for that year. You actually get it the next year. So varying your time since fire and the season in terms of where you're collecting seeds, you're going to get the greatest variety of seeds. Fire season has variable effects on woody dominance. This is the one that I hear a lot. People say, oh, burn during the summer, May, June, July, and you're going to reduce woody dominance. This one, I will tell you, really depends on a lot of different things as to whether you're going to see this result. Some studies have only used a single fire, tested only during a specific season. I'm going to explain later why that's potentially a problem. The biggest one in the most of the studies that I examined is that there was an inconsistent time since fire. So you can imagine, you've been looking at this photo series here, if you collect data 2 months after fire versus 9 months after fire, you're going to see a difference in that woody dominance. And so some of it is actually just confounding the season of burn effects with the time since burning. So in this example, if you're burning in December versus burning in July, you have more time between when you burned and when you're sampling. And so it's an artifact of time since burn and not necessarily season of burn. I'll also say this, we know that we get different fires depending on the conditions on the day of our burn. And so for instance, you might get a really patchy, low intensity burn during the dormant season, a higher intensity during the growing season. And so you might have more patches that maybe don't burn or don't burn as hot during the dormant season, just hypothetical, and you don't get as much mortality of the stems. And so what you're seeing are patches, in the fall, you're seeing patches of areas that actually did not burn. There are some studies that actually have no replication of their burn plots. So those are also studies where I would really question the results of those studies. So for instance, Austin Carey Forest, just outside of Gainesville, Florida. Has anybody been there? There's a beautiful summer annual plot. It's been burned every summer since the late 1970s. Right adjacent to it is a dormant season annual burned plot. It's about 30, 40 centimeters, few inches shorter, lower, in elevation than the summer annual. And we see that there's far more woody plants there. Is it the elevation or is it when we burn? I don't think we can answer that question. So there are other characteristics that we need to consider, and the fact that we don't have those replicated, we can't say whether it's some difference between those two areas or whether it's actually when they are burned, the season in which they are burned. And I'm just giving you these because these are things that these are questions you should ask, you should consider when people are saying that, fire has an effect on woody dominance. These are the questions you should be asking. Well, did you use a consistent time since fire? Is it replicated? And then what variables did you measure? Some people measure the number of stem resprouts, others measure biomass. So you can imagine if you have lots of little stems versus existing taller stems, there might be differences in biomass, but you've changed the structure of those woody plants, right? So changing the structure might have a different effect than just simply differences in biomass. Back to our same problem again, seasons are also not consistently defined. So asking people, what do you mean by dormant season? What do you mean by growing season? And then a lot of these studies focus on a single species. There was one that was done on water oak, where they found that burning during the summer influenced above ground biomass, reduced above ground biomass, but didn't reduce below ground biomass. So you still have the biomass there. You still have that potential for those plants then to resprout. But it didn't tell us anything about the structure. And we also know that the structure of our woody plants and the structure above ground will influence how they compete with other plants. So a lot of different things to consider here in terms of thinking about really how these species are affected. So I want to present one study to you that was long-term, and it was the effects of season of fire on woody dominance. They specifically measured biomass. They were consistent with time since fire. They had replication between plots. They checked all the boxes for me, okay? This study was done by Jeff Blitzenstein and others in St. Mark's National Wildlife Refuge. They examined the biomass, standardized with time since fire, and wanted to know what the effects of repeated seasonal fires were. They looked at plots in both sandhills and flatwoods. I can tell you the results were the same between them. They also did this repeatedly for about 25 years with fires every 2 years. And after every fire, then the next year, they collected and weighed biomass. No effects. Yeah, sorry, that should say biennial fires. No effect from biennial fires in different seasons. So these are plots that were separately burned during a specific season over time. That straight line means it doesn't differ from the null. Now, I want to point something out here. I don't think I have a pointer. Maybe I can use my thing. So for instance, say you were doing a study just in 1 year. You were studying a single fire during a single season. Say that you burned and studied it here. This is your pre-treatment. Then you burned and you studied it here. You would say that this lightning season fire had a negative effect on biomass. But you would see that it had more of a negative effect on the other burning during the dormant season. So our inter-year variation in the effects of fire is also going to affect that biomass. So it's important that we not just look at one single fire during a single season to be able to say anything about changes in woody dominance. Just sort of for curiosity's sake, I also put up, should say biennial fires during the lightning season. This also resulted in no change in grass biomass for the dormant season fires, November, January, February, but a decrease in grass biomass during the lightning season fire. So that's May, July, and August. Just because there's a decrease in biomass doesn't mean you're losing grass individuals. And in fact, if you look at the greater data set, you're not losing grass individuals. The frequency of occurrence, so the presence, absence in lots and lots of different plots, shows that they're still there. It's just the biomass is lower. Okay, you're not losing plants. You're just getting a little bit of a shift in the amount of biomass. We also looked at the long-term plant community data from frequently burned sites in Florida. This was an Avon Park bombing range, so a bit south of where that arrow is for St. Mark's National Wildlife Refuge. And I will say, I think the fancy font that I used is not, doesn't work on this computer, which is why all of my titles are a little wonky. Sorry about that. We wanted to know what were the effects of variable season, fire seasons on plant community composition. I will tell you, Avon Park, Air Force Range, has anybody been there? Yeah, it's amazing. They burn a lot. Whether they're lighting prescribed fires or they're dropping ordnance that then catch the areas on fire, they burn very, very frequently. In this area, we looked at a lot of different habitats, more mesic habitats, more xeric habitats, habitats in between. And Steve Orzel, Edwin Bridges, they've been collecting this data for over 30 years, really interested in how plant communities are changing, and the fire regimes are so variable there. And so we wanted to know over time, are we seeing any changes, especially in a lot of the dominant species that we know are important in these communities. Some of these locally dominant species include saw palmetto, Serrano repens, Quercus minima, the dwarf live oak, and of course, Urstia brickiana, wiregrass, okay? So we found that across all of the communities, these were relatively locally dominant. So within each plot, Serranoa or saw palmetto had about 16% of the cover. Wiregrass had 20, and then dwarf live oak had about 24%. So pretty dominant across all of these. We wanted to examine the demographic stability. So we wanted to see, are these communities staying super stable over time? And so we looked at the abundance of those dominant species in different open ecosystems over time. And then I'm also just going to show you another study. This was on wiregrass and whether populations of wiregrass are changing over time. Okay, so first, Avon Park Air Force Range. We found that dominant species, I'm actually showing you 5 here, are really remaining abundant over time, regardless of the fire regime. So there's a lot of variation in the fire regime here. Sometimes these are sampled after dormant season fires, sometimes after growing season fires. You never know when this area is going to burn. They only sampled after burning, so some of them weren't sampled as long as others. That's why you're seeing some blanks there in the graphs. Along the bottom or the x-axis, those are the years, and along the y-axis, that's the mean relative percent cover change. So they used percent cover and estimated it. Always the same people, so they had consistency through years. And the thing I want you to notice is that y-axis with the numbers, it only goes down to negative 0.2 and positive 0.2. That is so little in terms of cover. If you're doing a 1 meter square plot, 1% is about this much, right? Very, very little change over time for any of these. They're all extremely close to zero. And it's interesting, I can go out with botanists. I've gone out with Jeff Glitzenstein, and he takes us to a plot and he puts down the frame and he's got his little map of where the plants are in the plot. And he'll say, okay, this plant should be, yep, it's right there. And he's been sampling it for 30 years. So that tells us something about our open grassland systems here in Florida and really how stable they are over time. So let me give you another example. This one is specifically on wiregrass. Anyone who knows me knows I love wiregrass. I've been studying it for quite a few years. And this was a study that was done in Austin Carey Forest, North Central Florida, Ordway Swisher Biological Station, and then also Locluso Wildlife Management Area. So this is showing you data from multiple sites. We had about nine different units. Within each unit, we chose randomly individual wiregrass plants and tagged them. So over 1,000 individual plants tagged, followed for over 4 years. We wanted to know how their population was changing. So we collected all kinds of data on them. We looked at their size, their survival. Did they reproduce? How much did they reproduce? Did their seeds germinate? Every different component of the life cycle of these wiregrass plants. 1,000, over 1,000 plants. Yeah, I had a small army of undergraduates and technicians that were working on this sometimes. And then we put all of those numbers in and we did a bunch of, fancy modeling to get a number, and that's the population growth rate. Population growth rate is basically telling us, is a population increasing or is a population decreasing? So, for instance, 2 of you walk out of this room, our population is decreasing, right? 2 of you walk out of the room, but 2 walk back in at the same time, our population is staying the same. So we were really interested in, are these populations stable? And then what's causing them to be stable? Is it because 2 plants are dying and 2 plants are recruiting? Or is it because they're just persisting over time? The only thing I want you to see from this graph is it doesn't matter time since fire. The fire frequency, and these are all areas that had burned very frequently in the past. So this is the average fire frequency over the last 30 to 40 years. Nothing differs from 1. Nothing differs from 1. So there's no change. We didn't see any change in populations of wiregrass, extremely stable. Why? They survive. Wiregrass just survives. Now, did we have any mortality? Yeah, we had a couple unlucky plants that happened to be below a tree that fell. Those are the ones that died. Now, do I say they live indefinitely? No, they don't. But over the course of the 4 years that we studied these plants, we did not see mortality of any plants that just weren't really unlucky. So extremely, extremely stable. Variation in fire frequency, different fire seasons, stable. Now, these are mainly systems that we call these old growth grasslands. When you think of an old growth system, many people look at trees, right? But we have old growth grasslands here in the southeastern US along the Gulf Coastal Plain, and they are open ecosystems. They are defined as not having experienced a significant soil disturbance. They'll of course experience other disturbances, but these intact systems have these plants that are extremely stable over time. A lot of these species have similar characteristics, so they're resprouting. We have very, very few annual plants in a lot of our open ecosystems. We have a few, but not too many. They're traditionally long-lived. A good example of that is saw palmetto here. They've been dated to 15, 20,000 years old or older in the Lake Royals Ridge. So we know that some of these individuals can get very, very old, unless of course they're unlucky. Some of them do have fire-stimulated flowering. We do see that in wiregrass. They have amazing underground storage organs. I don't know if anyone's ever dug up any of these plants or ever seen some of these amazing root structures that some of our plants like our geoxyls will create, where they're huge bulbous root systems. And you can just imagine how much storage they have in those systems that help them remain stable over time. And then many of them have low seedling establishment. And we actually found that with wiregrass. When you're using wiregrass for restoration, you have a nice open prepared area for wiregrass, and we do see a lot of recruitment, but in these established populations, we don't see much, if at all, recruitment of wiregrass, even though we know these plants are producing seeds that will germinate. Why? Likely some sort of self-thinning mechanism, something like that. We have tested the soil. We know that's not the reason, but it's a characteristic of many of these plants. So you can ask me why about wiregrass, you can ask me why about any of these plants. So we have a lot of evidence that these plants persist, especially a lot of these dominant species, they persist under widely different fire regimes. Variation in frequency, variation in seasonality, they're persisting. And I love this little meme that was created by David over there. You know, the classic fire frequency, fire season, fire frequency, just burn it. You know, and that's, you know, that's sort of the message here is just burn it. And if you're burning, you're doing a great job. You're burning, you're doing a great job. Now, someone came up to me after the talk and I really appreciated it. I also got phone calls, I got emails, all kinds of stuff after the last talk, which I loved. And that's one of the reasons I asked to come back is because I do want to mention that there are reasons to target a specific season. It can help you meet your land management objectives, and it depends on what those objectives are. Each plant species has their own unique relationship with fire season. So if you are trying to target a specific season or a specific species, you may want to alter your season. Wiregrass is a good example of that, where you want to burn, you know, during the growing season. Okay. Where you want to burn during the growing season to enhance production of seeds that will germinate. But I do want to warn you that looking at the results of burning one time during a specific season can be a bit of an optical illusion. So for instance, we know with wiregrass that the precipitation following a burn is actually going to influence the number of filled seeds. So that's, you know, could be sometimes a bit hard to predict how much precipitation you're going to get immediately after a burn. So you're going to see, you know, variation between fires and the results that you have. And I would also say if someone tells you, oh yeah, I you know, lit a growing season fire and it really reduced the dominance of woody species, ask them, well, what are you looking at? Are you looking at the structure? Are you like looking at the biomass? What is that factor that you're looking at? Because some of those are in contrast to each other in terms of how they're measured. You might have a lot of biomass, but you might have a short stature of the plant with lots of different sprouts. And that structure is going to make a difference in competition with grasses and forbs. Operationally, it might just be easier to burn at a specific time. Hey, you know, during the spring, you know, during March, we had all the people we could ever want to light a prescribed fire. We had great weather conditions, but we're sort of risking that we're going to be able to get those conditions, to get those people during the summer. You know, it's been 4 years, 5 years, 6 years since we burned this. You know, operationally, you might burn during a specific season to meet those, you know, land management objectives, even if you're not specifically focusing on, you know, one particular aspect of it or one particular species. I will also say burning during a specific season, it can alter the woody structure. I think that's a lot of what people are seeing in terms of changes in dominance, but they're still there. They're not going anywhere. They're still there. Certainly pollinator resources and maybe pollinator resources during a critical time during the fall, in addition to production of viable seeds for some species and seed availability for the little critters that enjoy eating those seeds, especially during the fall, ants and so on and so forth. And I didn't get into some of the seasonal effects that there might be on wildlife. I study plants, but Dr. Baruzzi, I'm sure could answer a lot of those questions, may answer them during her talk or even afterwards. And lots of people, I mean, I've presented a lot of my own research. I've also presented the research of others. I'm happy to provide any papers, resources, this talk, anything that you might be interested in. You know, consider me a resource even into the future. If you have a question about, you know, what you're doing or decisions you're making, I'm happy to tell you, you know, what I know or what the literature knows, or even help connect you with someone who might know far more than I do. You can find me at ecologyonfire.com. My phone number is there. My email address is there. Feel free to reach out if you have any questions. And I don't know if I have time now.